Alright, now we're ready for problem 2. Mr. Gall starts braking his car at time equals 0. His velocity changes at a constant rate as the car skids from 60 to 0 over an 8-second time interval. Alright, part A. Draw the velocity graph versus time for this car. Alright, so some of you need to take that time to read the problem. At a time of 0, he's starting with a speed of 60, and he's slowing down to a speed of 0. He's slowing down in this problem. He's braking his car. Slamming on the brakes. Alright, so let's show that on our graph. We know he's starting with a speed of 60. So a lot of things are done on this graph for us. We have our time axis scaled. We have labels for each axis. A lot is done. We just don't have a scale for this velocity axis. So let's scale that out. We know we have to start with the speed of 60. So to fit that well on this axis, I'm going to go by every 3 boxes. And just go 20, 40, 60. If you didn't use that same scale, it's okay, but that's a nice one to kind of spread out your data. Alright, at a time of 0, he started with a speed of 60. Over an 8-second time interval, he slowed down to a speed of 0. So this velocity that starts at 60, it gets slower, 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 slower. At a time of 8 seconds, he's reached a speed of 0. So our velocity graph for this problem will be just a straight line that connects those 2 points. We have a line from 60 down to 0 in 8 seconds. Part B, calculate the acceleration of the car. Show your calculation in detail. Just like the last problem, acceleration on a velocity graph is simply the slope. So that's the easiest way to do it. That's what I'll show you. On this problem, the slope is rise, so we're going downward, it's negative, divided by run. The rise, it dropped the full 60, so our rise is a negative, because it's going downward, 60. Our run is the full 8 seconds. So for acceleration on this problem, our rise, negative 60, divided by our run of 8, gives you your answer. If you type that in the calculator, negative 60 divided by 8 gives you your final answer. Negative 7.5 if you typed it in correctly. Alright, now our last part. So here's that graph we just made. Part C says, how far did the car skid in the first 4 seconds? Alright, they're asking how far. That's delta x. Let's keep that in mind. Alright, so you might like to use the guess method for this problem because it's an equation type problem. So let's write down what we know, givens. We know this velocity is starting at 60. So velocity initial for this is 60. We just found the acceleration in the last problem. It was the negative 7.5 that we calculated. And now, I know this object moves, the car moves for 8 seconds, but they only care about the first 4 seconds. So for this, part C, our delta t is just going to be 4. Unknown. What they asked us to find is that delta x. And we have an equation for that. It's motion equation number 2. Delta x equals vi times t. I'm going to have to write it down here, plus the 1/2 acceleration times time squared. We're going to plug into this equation. Alright, I'm going to span this throughout both boxes here. So delta x is equal to our velocity initial, which we said was 60, multiplied by time. So the time was 4 seconds, plus 1/2 our acceleration, which is a negative 7.5, times our time, which is 4 again, but we have to square it. Okay, so solving this mathematically, what you'll do each side separately, so 60 times 4 gives you 240. On this side, since we have an exponent, that's our first step. We have to square the 4 first. So we have 1/2 times a negative 7.5. 4 squared is 16. So that's what we'll multiply by. So 1/2 of negative 7.5 times 16. If you do that correctly, when you multiply those 3 together, you'll get a negative 60. So your final answer, delta x, the distance, 240 minus 60, gives you a negative, or sorry, not a negative, a positive 180. So 180 meters is your answer for this one. It's a distance, so the label is meters. Make sure you have that.